Hey everyone, my name is Ashik Ram, and I'm joined by Abdullah Koker, and we are the co-hosts of the podcast, The Second Curve. So essentially, this podcast focuses on, the second curve of learning that people often go through in their career, and along with the stories and different experiences that shaped who they are today. So essentially, our goal is to take these stories and share them, along with uncovering what the next big thing will be in our industry.
And so today we're joined by Rahul, currently an AI/ML engineer at Google. So, hi Rahul, how are you doing? For the viewers, could you just give like a quick description about who you are, what you do?
Sure. I am a AIML engineer at Google. I work with customers and help them use Google Cloud AI solutions to kind of develop their products and applications. I help them make best use of Google Cloud products, and I have a background of professional architecture, solutions architecture, and professional architecture. So I kind of come in with that kind of lens, helping with the systems kind of understanding in developing AI solutions rather than thinking of just as a input and output variables.
Nice. And when, we were looking at, your profile before when we were prepping for this podcast, we saw that you worked at Deloitte before you worked at Google. Do you think you liked Deloitte more or Google in your, experience?
So a lot of times people think Google has been my dream job, but actually Deloitte was my dream job. I never dreamt of being at Google, probably because I thought I'd never get to Google. But more of a reason was when I was during my undergraduation, Deloitte came to do campus placements in India. We have this program where different companies come, interviews over multiple days, and hire people. I got rejected by Deloitte at that time. So for me, it was a point of like proving it to myself that I can get back into Deloitte. After my master's, when I was looking for good opportunities, I wanted to work in cloud computing. I wanted to work in consulting because you get to travel. I wanted to kind of go to new places. I was a young kid, like bachelor, just graduated from school in US without parent supervision. So I wanted to kind of exploit that fully, right? So Deloitte seemed like the kind of dream job that I want to go to. I was fortunate enough to have a few friends who referred me to Deloitte, and I interviewed multiple times. I got in, but the job was not as rosy as I imagined it to be. But it was definitely dog years for me. The 3 years I worked at Deloitte was like 20 years of experience. I kind of worked really hard. Consulting life was really hard. But when I wanted to kind of get out of being that hard on me for with work, I wanted to kind of settle down into something more that I can have a work-life balance. And also I wanted to kind of, at Deloitte, I was focusing very much on cloud security. I wanted to focus on broader cloud aspects, not just like on security. So when the opportunity at Google came knocking, it was no brainer for me to kind of jump the ships. I think thinking whether Deloitte was good or Google is good is a very wrong way for me. I wouldn't say wrong way for others, but for me, because at that point of my career where I just started my career, Deloitte was the perfect fit for me because it helped me learn a lot of things very quickly and kind of be in a very challenging positions and kind of solving really interesting problems. And working more hours was something that I needed to do to kind of be where I am today. And Google, now I have a 2-year-old daughter, and I want to spend good time with my daughter. Being at Google is the best thing for me now because it gives me both ability to work on great challenges, incredible problems, but also have a balance in life that I can kind of come back home and be with my family.
Yeah,
Yeah. And
that's great to hear. You talked a lot about how it was like almost like two stages, would you say, of your career. Um, in the first part where you worked a lot harder and like harder hours, and now it's like coming out to work-life balance. And just quickly, if for the people who maybe don't know as much about cloud computing, could you give like a 2 or 3 sentence like description for someone like for the uninitiated as to what exactly is cloud computing and like what do you do inside of it?
Sure. So let me start with internet. What internet is, right? Internet is essentially you have your computer in front of you. You have some files in your computer. For me to access those files, you're providing a network, kind of plumbing for water to pass from one place to another. Your data bits need to pass from one place to another. And I should be able to come to your computer, access that file. That is, the file is nothing but it could be anything, right? It could be just a Word file that you kind of wrote and published as a blog, exposed to the internet as a blog. It could be a website like Amazon.com, right? It could be a very complicated website. It could be any kind of files. Now, if there is only one person coming and looking at your files, or like 10 people coming and looking at your files, you don't need a very complicated computer in front of you. You can publish a website from your laptop itself. But if you need a website like at the scale of Amazon, you need a very sophisticated application stack, very powerful computers that can handle that kind of traffic, handle that many web pages and all these things, handle a lot of bells and whistles that the complicated websites need. Now, that is a rack of computers. That is a bunch of servers. Now, some companies host their own servers because it gives them more control over what kind of infrastructure that is hosting their websites. But many companies don't require that. Like Amazon requires to maintain its own servers, but there are many smaller shops. Macy's want a website, e-commerce website, because they need a presence on the internet. They don't need a very complicated server rack and employees to kind of maintain that server rack. That's when they go to third parties to kind of help them with this. The data center business started like that. But customers wanted more from not just hosting your servers, but they wanted this technology that the best companies use, like Google, Amazon. They kind of built very custom technologies, very interesting technologies. Like take AI, for example. Google has developed AI for internal purposes, for Google to use it or kind of expose it as products. But where other customers also want to kind of get hands on that kind of technology. So Google is providing the technology as part of the Google Cloud Platform. So that is what essentially cloud computing is. You are hosting your websites or whatever on Google managed infrastructure, and Google provides you with extreme levels of customization. You can just give us code and we will maintain that code, try like deploy that code and everything, or you can deploy your code on your own infrastructure and everything. It's a very varied options that they provide to you to kind of run your website and focus on what is important to your business.
Yeah. So, that's very cool what you do. I just wanted to circle back on, your journey from, starting out from consulting now to, using computer engineering cloud in Google. So I know you touched upon this a little bit before, talking about computer engineering, but how would you describe, your first journey from starting out in consulting to now what you're doing at Google today? Just for the viewers.
Sure. During my master's, I came to do my master's, but I didn't know what kind of job I wanted. I just wanted to kind of find. I had this dream of getting into consulting, specifically at Deloitte, but I don't know what kind of job I'll do at Deloitte. I don't know what excites me, or what is a piece of technology that I want to work on. I thought like the computer networking masters that I was doing, that was good but not exciting. Then I did an internship at Nokia. During that internship, I got really exposed to cloud computing for the first time. I was working with this team which was acting as an internal cloud provider for the internal teams, basically providing them ability to kind of create virtual machines automatically without having other teams maintain their own infrastructure. This was the first time I got that exposure, and it kind of really excited me a lot. And the ability, the kind of democratization that happens with this kind of technology is insane. Anyone, like if you see the startup ecosystem right now, it's vibrant because of cloud computing, because they need not work on bringing the capital to buy their own servers to kind of test out their theories or test out their application, whether their e-commerce website will work or not. Take Lenskart or any internet-born website today, for example, right? Earlier, they had to go and buy their infrastructure first, which used to be very, very expensive thing to do. But now they can just come and host their application on a cloud provider and just start their business, try out different things, try out that kind of democratization of technology is something that kind of excited me a lot. And I kind of wanted to continue working on that. I went and got my AWS, Amazon Web Services certifications for associate level, entry level people. I did like They have three certifications. I did those three certifications. Then I started applying for jobs. My first job was at a telematics company called Calamp, where they wanted me to kind of help them migrate to cloud, but they were like ingrained in so much of regulations because they were working with law enforcement to help um, retrieve stolen vehicles. So they had a lot of law enforcement data in their application and their databases. So they had a lot of regulations and kind of red taping, preventing them from moving to cloud. However, how much ever you try to explain, it's very difficult, like as an entry-level systems engineer, to kind of go and convince leadership that the regulations will not be a problem. So then I wanted to kind of get back into working in the cloud computing. Then I joined Deloitte. I worked with various customers, helping them with their security needs very specifically. I was helping them secure their cloud environments. Most of the customers, they are moving from a data center environment to cloud environment, which is very, and you, they, it is a common misconception that security is handled by the cloud service provider, but there's a lot of customization that you need to do, a lot of your own configuration that you need to do. So we were doing assessments for them and helping them, giving recommendations and how they have to do their security. As I mentioned earlier, I wanted to move into something broader than just security. So at Google, I joined as a technical account manager. I was helping customers with their end-to-end cloud journey, being successful at Google with Google Cloud products. And now I kind of pivoted into a AI/ML specialist role where I'm focusing very specifically on AI/ML products at Google, and that is where the future is, AI. Hence, it made sense for me to kind of make that pivot, which was quite difficult, but quite interesting as well. It was a 2.5 year learning journey for me, almost like another master's in AI, and kind of start building my reputation and eventually securing a job role within the company, and now working with customers. I'm developing demos for them. I'm creating presentations and best practices on how to work with Google AI products. So yeah, exciting journey.
Yeah, it really is. A lot of people are saying, and a lot of proof has been shown that AI is definitely where things are headed. And eh, what do you think? Like, I think it's kind of interesting making that almost second pivot now to AIML. That's what we focus on here. The second curve, that whole 2 years, almost second masters that you had. If you could just like expand a little bit upon that, maybe like one or two things that you really like about AI and specifically, or maybe something that was there like a moment or like a situation that really drove you to be like, yeah, no, this is the future. I need to start getting in on this?
Yeah, so I think in 2017, 2018, around that time when I finished my master's, I was kind of learning cloud computing, but I wanted to kind of get into AI as well because I was looking at the now Waymo company, which was making a lot of waves, like the computational neural networks and the autonomous cars, and that was a very interesting problem everyone was trying to solve. And Udacity was a website that we had. I think we still do. They offer these programs as nano degrees and they teach you a lot of things. And I almost went and signed up for the AI course that they were teaching. Like, I was super excited about that. But then I got kind of distracted with the Deloitte offer and the interviews that I need to prepare for Deloitte and everything. And then I joined Deloitte. Security was also new for me. And security also was very, very hot. Like, it was very interesting. So, and I didn't have a formal education training in security. So I had to kind of upskill myself over there and work with customers. So I kind of put the AI thing aside. Then for a few years, it went like in the auto drive mode kind of thing. And then when the generative AI train hit, a lot of people got into AI and they started kind of seeing the potential of what AI can do. That was a moment kind of I realized, okay, I need to get back into AI. I kind of diverged a little bit. Let me get back. I'm not regretting any of the decisions that I made previously because that helped me give a lot of more perspective as a more systems thinker. Because I'll get into that a little bit later. But I started learning about AI, doing fundamentals, did a lot of interesting courses. There are a ton of sources over the internet, right? I would say just go look for what excites you more, what kind of helps you more. For me, I started with Andrew Yang's videos on deep learning website. He's the founder of Udacity, I think. It was he's founder of Coursera, my bad. And he explains machine learning. He makes it look so simple. I haven't found any other instructor who can do that at that level. I felt like he was kind of peeling the banana and feeding me the banana. That's how beautiful his explanations were. But for me to internalize the concepts, it took way longer. For me, understanding basic concepts like there is a basic concept called backpropagation in machine learning, where that is how models learn. They kind of see where they are doing mistakes and they kind of improve the network and model. That happens by the algorithm called backpropagation. For me, understanding our backpropagation 2 years back and understanding now is vastly different, because it's not just about going and reading again and again. It's also about giving it sufficient time for us to kind of internalize that and help our brain connect the dots. So, second curve or second shift, I think you just need not do just one shift in life, especially for folks who are way younger. Your world will topple every few years. It will keep changing. The idea is to kind of be a very, very fast learner and also understand what to learn and what not to learn, right? If you can be resourceful enough to find the right resources very, very quickly, your learning curve will be very, very fast. And if that doesn't mean you don't try new things, you have to try multiple things and see what clicks for you. For me, the example of Andrew Wang's videos was one of those, right? I tried different videos. None of them, like, they were very complicated or very, very simple, which is not addressing what I wanted. Andrew Wang's videos was perfect fit. But then I moved on, right? From fundamentals to I wanted systems level understanding. In machine learning, you can either be a model developer, like Google DeepMind, going into a research mode and kind of helping build new models, coming up with new technologies or architectures. Or you can use the technology that is already built or use the architectures that were already built and adapt to new scenarios. For example, Tesla uses image recognition and video recognition to kind of develop autonomous vehicles, right? Same image recognition technology can be used in medicine for a different purpose, like radiology and this kind of things. It can be used in factory floors for different technology. So the same architectures, the same innovation that is made at one place can be adopted at multiple places. I wanted to be there. I wanted to actually build applications based on using ML and AI technologies. And that's where I was telling about, like, all my past experience as a systems thinker, as a professional architect, helped me be the second part of AI, which is actually developing systems thinking. And that is when I kind of came across Chip Huen's books and lectures. Chip Huen is another Stanford lecturer, amazing author in ML system design and AI engineering books. I would greatly recommend everyone to kind of check it out for getting real world understanding of ML, not the academic or research way of doing machine learning, but actually systems way of doing machine learning. How does Google does machine learning? How does Uber does machine learning? What do they do? What kind of models they build? So that was the interesting part for me. And I kind of pivoted from academic ML to kind of systems thinking ML. That I wouldn't have known what to do unless I started somewhere. So in order to make your second pivot or any pivot continuous pivots, I would say you have to get started just drilling down, going down that rabbit hole, understanding what makes sense and what doesn't make sense for you, and keep pivoting, keep changing, keep iterating. Classic ML terms, you have to iterate your model learning multiple times to kind of create that perfect model.
Yeah,
Yeah, no, you
that
mentioned
is
sorry. Yeah, you mentioned Andrew Ng's courses. Yeah, I went through the supervised learning one and some of the other ones as well. It's amazing the way he explains things. It's very accessible to people, even if you don't have a very like heavy math background. But if you do, he has the optional math explanations as well for, you know, a math person. It can really help solidify some of the topics.
The
And
math
yeah, like
they taught was something I learned during my engineering days, like undergraduation days. It was so exciting to kind of go back into that kind of math. Honestly, I didn't understood half of it. Probably 80, 90% of it. I didn't understand. the goal is not to kind of understand it. Like the
Yeah.
goal is not to kind of go and repeat that math or something like that. It's to understand the intuition behind it.
Yeah, definitely.
And Three Blue One Brown is a YouTube channel that I would recommend
Hmm.
to understand the math intuition. It is amazing. They explain the intuition behind like curves, functions, and all these things really well. I wish more schools did the same thing.
Yeah, definitely.
Yeah. And I think you touched upon when you were talking, about your second curve, about things you tried like to unlearn. So is there anything like in particular that, stood out that you just had to unlearn, in your second pivot?
I think for a lot of unlearning was very quick for me in the machine learning sense. The reason being, I started with academic. That's how everyone starts, right? You want to kind of understand the fundamentals, the underlying stuff, and everything. But in the real world scenarios, that is not what you want. I'll give you an example, right? In research world, they focus a lot on accuracy. For example, accuracy of a model. They want the model to kind of like from 98 to 99% improving the accuracy from 98% to 99%. They work years to get there. But in real world, the value is not from moving from 98 to 99%, but actually how quickly you can bring the product to the market. Because if you're waiting for 3 years to kind of improve the accuracy of your model, you're already out of market because customers also don't want that kind of accuracy. There are very few edge cases that don't work unless like you're working in a field like autonomous systems, where your edge cases can lead to kind of accidents or human damage or property damage. That's where your accuracy absolutely matters a lot. But not all applications are like that. Take Uber, for example, where they're identifying how to match the right driver to you. They are using an ML algorithm to match the right driver. They are looking at the nearest drivers. They are looking at what rating you have as a customer, what rating the driver has as a customer, how loyal you are to Uber. So let me send a good driver to you, a driver with higher ratings to you. But if if the model is not accurate in sending a right driver, it is sending a driver slightly not that great of compared to the best driver they have, your experience wouldn't change much, right? Like you're not like, it's not going to be like, I'm not never going to get on Uber again. That model is not that important. But if Lyft is coming with that model very quickly and they're trying to do match with a good driver for 90% of times instead of 98% of times, Lyft is providing a better experience than Uber is doing, right? So in commercial or enterprise world, speed to market is more important than accuracy. That is something I had to unlearn, because whatever I'm learning in academic setting is to kind of how to get to that best model, how to get to improve the accuracy, how to kind of. But when you're going into real world scenarios, there are a lot of components, not just the ML, that kind of leads to the best model, best outcome, and you're working on the combined aspects of getting to the best outcome instead of getting to the best accuracy or best outcome of the model itself.
Yeah, no, I've seen that a lot with startups recently, a lot of the Silicon Valley startups, where it's like, at the end of the day, you're talking, if it doesn't match the perfect driver to the perfect, customer, your experience doesn't change. The thing that matters the most is, does it work and does it work fast? So, the only time it would be a problem for the customer is if you're not paired with a driver. Then your experience is bad. So, or if it takes, 5 minutes to pair you with a driver, even if it's 99% accuracy, I, as the customer, want it to be done in 10 seconds. So
Exactly.
it's almost like that flip from like, it needs to be perfect to, can we get it out the door? Does it really matter for the customer at that point?
Yeah. It's very cool when you said like, how you're trying to it was easy for you to, unlearn um things compared to other people. I think, for me taking time to unlearn things, I think takes longer. So that's, very cool what you did. And
Why do you think it takes longer for you to unlearn things?
I think, well, since I'm in like still in academics, if I'm learning something right now, to unlearn it, I've probably already ingrained it in my brain for like a long time. And to unlearn it, like let's just say I'm, trying this like new math problem, like new, strategy that I learned. To unlearn it, if I kept doing that math problem so many times, that strategy would just never go away. So I think it's just like, much harder for me to unlearn things. But, changing to that second pivot, you need to unlearn the things, especially when you're coming out of an academic background.
Yeah, I think moving from academic to real world or enterprise world would be certainly interesting change. A lot of concepts that we kind of understand innately or intuitively are very different in the real world. But how quickly you adapt. And one tip that helped me was, what is my outcome here? My outcome is not to apply what I know. My outcome is to kind of do what's best for the other person, right? When you kind of flip that frame of mind, and kind of move into a learning mindset of doing what is best for the outcome that is needed, and thinking that, yes, I can learn whatever I need to very quickly, that would be key to success, especially in the world of AI. When things are changing so rapidly, you should be able to quickly shift your mindset accordingly, quickly start learning new things. So if doing anything now during the academic world helps with kind of making that pivot, I would love to learn your perspective. Like, what do you think would help you learn faster, learn make that mindset shift quicker, and kind of unlearn those academic things and learn real world challenges very quickly? What do you think?
I think that, before getting into that, just like a quick note on that difference from academic to like real world. I think sometimes that's where people struggle, especially in interviews or in getting jobs, especially in computer science, because you do your degree in computer science, but it doesn't teach you how to be an AI ML engineer. It doesn't teach you how to be a software engineer. It'll teach you a lot of the theory, but a lot of the application comes along with that. And I think one thing that would maybe help students is acknowledging, like in curriculums, acknowledging the importance of theory, throwing in a lot of like real world, like getting students to balance theory and application, where it's great to do your own projects or figure out how stuff works in a production environment, because a lot of the times undergraduate students haven't touched a production environment ever, and it's going to be difficult for them going into a first job or like an internship, and having to figure out how to use like version control stuff like GitHub or Git in general. So I think maybe having like almost like real world practical like workshops, or integrating those into classes, or even just giving a more emphasis on the fact that students should be introduced and should be working a lot in production environments, even with their academics. I don't know if you have any thoughts on that, or maybe your own experience in undergrad, and that kind of switch.
Forget about the production environment. My undergraduation, I didn't even have access to a dev environment. It was highly theoretical. And we were doing a few projects, but nothing close to what the real world has to offer, right? I personally wouldn't wait for someone to provide me with the right set of tools or environment to go and succeed when I know what I need. A lot of the times, the problem is I don't even know what I want, right? Especially during my undergraduation, I didn't even know about the production environments, dev environments. I didn't even know that I wanted access to something. Had I known, probably I would have approached it very differently. So what what you both are doing is quite incredible in terms of at least giving people that exposure. Like, okay, there's the academic world is very different from the professional world, and you want to provide that view into the professional world, which is pretty amazing, right? Now that you have that exposure, how do you go about it? Building projects, as you said, Abdullah, is pretty incredible way to start. There are a ton of engineering blogs out there, that like Netflix has their engineering blog. I go and learn a lot from there, how Netflix is implementing certain things. Be curious about it. Like, now that I said to you, isn't it curious to you kind of go and see what how Netflix is built? Like, you immediately want to go and read about it, right? I would kind of do that, like go check out different engineering blogs, how they are doing things. Follow people who are doing amazing things on LinkedIn or on Twitter. Andrew Kapathi for machine learning. He's a director of AI at Tesla. I think he is now at OpenAI. People like them, they're posting a lot of interesting things. Even if you don't understand anything, that will give you exposure to things that you are not usually exposed to in an academic setting. So what academics is teaching is also pretty incredible, right? Like, people who have interest into going into more academics, like teaching or developing research models, continuing doing a PhD to kind of creating new algorithms or researching on new techniques and algorithms. That's pretty incredible too. Whatever you're learning in your academic setting continues to kind of help you grow there. But whatever you want in your corporate or enterprise world, but I think it's a little bit difficult to acquire from the academic setting. So you need to kind of do things like this, where you're following different people, reading blogs, real world blogs and stuff, trying to understand how things happen in real life. I think that will help.
Yeah, definitely. It's great that you touched upon like, how it's important to, have that academic aspect, but also, touch more upon and understand, the real world aspect. And that's why I want to like go into the next part and asking you about, you're a specialist in AI ML. I want to go more into the AI side and talk about, how your role at Google emphasizes that. You've already touched upon it, but because of your LinkedIn posts, I want you to, explain some of that to the viewers and also talk about, the role of startups in AI because, so many different startups being created every day. So I just want to, have your input on that.
Yeah, people have a lot of different opinions on the startups right now, like very, very young people, whether it be dropping out or maybe getting kicked out of university and starting, going to San Francisco and doing all these startups. Just want to get your, thoughts on that.
I don't want to sit here and pass any judgments or give any guidance on how you can be successful in that way, right? Because there could be a Mark Zuckerberg coming from your school, and there could be people who are doing challenging things which I could never imagine doing. I can never imagine dropping out of school and doing something. So since I cannot imagine, I cannot give any guidance on that, and that is wrong, right? Like, because that many people became successful that way. What I can tell is that this is certainly a really interesting moment in our what there is a book called Prediction Machines. The Prediction Machines is written by a few professors in Canada, AI professors. They particularly studied about economics of AI, and many people are. If you look at the news, everyone is like, "Where is the economy? Why is AI not creating a greater economy yet? Why are we not seeing the results yet?" And all these questions, they answer all of those very beautifully, and they did that long back, a few years back actually. What they say in the book is that we are living in between times. So let us take electricity for example. Right now electricity is at your doorstep. You don't even, it's abstracted to a point where you don't even know how it's coming to your house, right? You vaguely know that there are some wires outside. There is a transformer at the end of your street or end of your colony that is bringing from the power grid, and probably dams are creating some electricity, and it is passing to you. Unless you are a very, very curious person who has researched a lot about it, this is, at least this is all I know about electricity. It is abstracted to a point where you're just using electricity without even knowing how it is coming to your footstep. Now, when you look at um, 1950s, 1960s, when electricity just started. Sorry, I don't even know when electricity just started. It's probably even before that. But when it just started, the point is, it didn't start like this. It was a point solution. What I mean by point solution is, it was every factory, big factory probably had their own electricity generator or a transformer, and not a lot of normal houses didn't even have any electricity. Whichever, wherever the need is, they probably transported the electricity on a vehicle or something like that, on a transformer. Most of the current is not even alternative current, it's direct current, which is through a battery or something like that. It is not even generated the way it is generated right now using solar power, nuclear power, or hydropower, right? And this kind of seamlessness happened over years. It took multiple years to kind of establish that network and get electricity lines to our homes to a point where it is abstracted what we have today. Now, for AI, we are in those early electricity days. A lot of it is being implemented as a point solution, or it is just being adapted as a more widespread solution. So for us to kind of see the impact of AI, a lot of people are looking at it as a very near-term, immediate thing and trying to understand, hey, what's going on? What's happening? But the true potential of AI is after this in-between times, where it is so seamless that you don't even know that it is there, or you don't even, it is abstracted to a point where it is not there. That is why Sundar Pichai said that AI is a pivotal movement. It is like more like inventing electricity, not even inventing internet or anything like that. Now, when you think about that way, it is fundamentally so transformative that no one truly understands what the future is going to look like. If someone is saying with certainty, this is what is the future, I would say, don't run away from that interview. Don't believe. It can be the brightest minds on earth, but it's very, very hard to predict what the future looks like. I'll give you another example. Right? When electric bulb was invented, it was so expensive that only few people were able to use it. It was not in every home like you and me. It was probably in few factories, few government buildings like that. As electricity became cheaper and as manufacturing electric bulbs became cheaper, it became so prevalent and it entered every other area. Now, even our staircase has a LED lights that is motion detected and switched on where I walk over there, right? Now, lights is such a commonplace. Now, AI would be something similar. The thing about AI right now is getting a prediction has become very, very cheaper. Now, wherever prediction makes things much cheaper for future, all that areas will change. If I can, for example, if I can predict whether there will be rainfall tomorrow or not, I will have good ability to know how to plan my day tomorrow, right? How a farmer can, whether they have to sow the seeds tomorrow or not, whether they have to, how they have to plan. Now, giving farmer this kind of tool set about weather is very difficult today, right? Because first of all, predicting weather is a very difficult problem, and even if you're doing it, it is a very costly problem, very expensive. But if you can provide, if you can make it very cheap and give it to a farmer, it makes the huge difference to the farmer's life, right? That is what we are going to see in the future. As predictions become much cheaper, it will penetrate into areas which we do not know or which we cannot see. As electricity and electric bulbs became cheaper, it got into areas where we can't even imagine. It went into a vehicle, it went into a camera, it went into the laptop, it went into our mobile phones as a touch. It went into every place, right? That is what we'll see with AI as well. It's becoming cheaper. It will get into every place that we can't even imagine. I don't think Thomas Alva Edison imagined it to be used as a motion detecting light sensor. I'm sure when he invented electric bulb, he wouldn't have imagined of this being there. So anyone who is working in AI, even the brightest minds today, it will be just like Thomas Alva Edison not imagining how light bulb will be used today.
Yeah, that's a really, really insightful and an interesting perspective that I actually hadn't even thought of beforehand. That like, with all of these lights, like my keyboard is lighting up, right? Like it's to the point where now systems are being built upon that, right? I don't care how my electricity is getting to me. I care what I do on my computer with that electricity. So it could be in the future, it's not that it's just AI and like you kind of know you're using it. It's now systems that are built on top of AI that people are working on, and AI is just like the fundamental base. Yeah, it's a given, right? It's a really, really interesting thing, and yeah, no one can really predict what's going on in the next month, week, even day. You really can't tell. And it'll be interesting to see how people will adapt to it, how people's habits will change in accordance to it. As a lot of things were turned completely upside down with electricity, entire new industries were made. So it would be really cool to see what industries are made or even improved with AI becoming like a given, like a baseline.
Yeah, and to answer your earlier question, whether what should students do today? Like, should they leave their colleges, go and make most of the gold rush that is happening, the AI rush that is happening? I would say, like, if you have an amazing idea of how value will be created, the goal of a company is to create value for its users. If you think there is a incredible potential to kind of create amazing value to your customers, to your users, go and check it out. But at the same time, don't be in a FOMO where if you're not doing it right now, you're going to miss out on something else, something huge. iPhone was came with um, I think early 2000s. Uber didn't come until late 2000s. Uber is the app that is was only possible because of the app store that the smartphones had. If there is no concept of smartphone app store, there wouldn't be a Uber application today. But it didn't happen the next day when app stores came out. It came after a few years. Whereas there were some applications that came immediately. Like there was an application to switch on the flashlight in your camera, which was immediately Apple introduced in the next model or next software revision. They introduced that as a feature within the Apple phone. That app is gone. It's not there anymore. So the risk of moving very fast is sometimes you will get on things that can be solved by someone else very, very easily. You want to work on problems that are really, really challenging. Think of really complex problems, really challenging problems. How would you like? I would kind of give that as an exercise. Whoever is watching, like, what is the most challenging thing that you came across in the last 1 month or 2 months? It could be booking tickets for a favorite concert, or it could be paying your utility bill or anything like that, right? Like find a very, very complex problem you came across, you heard, you read, start thinking about how you can solve. And if you can solve it really well with the latest tool set, with the technology that we have today, solving that will give incredible value to someone else, then yeah, go and solve that problem. Go and do that immediately. But if you are solving, switching on a light, off and on a light on an iPhone, which may or may not bring too much value to anyone, I would say, hold on. You're not missing out on a lot of things. Waiting and amassing knowledge will eventually get there. Don't be in a hurry to kind of make a lot of money.
Yeah. And just as you said, like try to build and start quickly. And so many startups, like if you can, like today, so many startups are probably like, entering into like the Y Combinator. As you would see, like before, like maybe like 2 or 3 startups, maybe in a month, like, 10 years ago compared to now, so many more startups in that month. So, it's so cool. And like an example of, you said, see a complex problem and then make sure it helps other people. That one Ivy League dropout that made Cal AI, the calorie like tracking app. That was a pretty complex problem, but he helped so many people, and so many people use that app, right? So I think you gave great insight in saying like you should create something that will help and be useful for others. So
Yeah,
I
not
think that
not
was very
something
cool.
that can be solved by Sam Altman in the next GPT update.
Exactly.
You see a lot of the, every couple of weeks you see another headline, 200 AI startups are being killed by Sam Altman, with, GPT agent or whatever, right? I think that
Your
aligns with.
purpose is to kind of create incredible value. And if you're
Mhm.
not solving a very, very complex problem, you're not creating a lot of value.
Right.
And if your purpose is just to make money, then there are a lot of easier ways to make money than starting a startup.
Exactly. Yeah. And to wrap things up, I just want to, for the viewers, if you were a student today, you already talked about like what other students could do, but what would you do differently now if you were just, you're getting right out of college, fresh out of college? What is one thing you would take advantage of in the job market, regarding AI and ML?
If I were to start today as a student, I would probably start with talking to more people about not just AI, things in general. The real potential of AI is in applying AI, applying this technology to solve interesting problems. And what are those interesting problems? Like, I would talk to more people, try to understand, because the technology is there. How do you solve it? There are people who know how to solve it. You can work with those people. You can think about it. You have this PhD level assistants, ChatGPT, Gemini, to kind of help you with brainstorming, help you with kind of understanding how to solve the problem. The thing that I think is still missing is a lot of understanding of what the complex problem is. We are immediately rushing into solution mode, and we are not trying to truly understand what the problem is. And that when we understand what truly the problem is and try to solve it, that will flip the way we solve problems. I'll give you a small example, right? This is also an example of what prediction machine stated. They gave a thought experiment. Amazon is, you go into Amazon, look at the product, it does good job in recommending what you want, what is a kind of brand or product that you want, and helps you buy it. But imagine a situation where Amazon's prediction about you and what you want becomes so amazing that they can just ship what you want before you know that you need it or not. Right? Now, what is the risk for Amazon? They send something to you, you say, I don't want it, you return it. The return cost. Right now, the return cost is so high that they cannot do this or go and ship things to you before you order them, right? But if Amazon's machine learning becomes so amazing, this entire model is flipped. They are not order and ship, they are ship and return business. What is the advantage for Amazon? Now, if I need a dishwash soap in my house and Amazon knows that I need dishwash soap and they sent it to me, I'm not going to a CVS tomorrow morning when my wife yells at me, where is the dish soap? And I'm immediately rushing to CVS to get the dish soap, right? I'm ordering, Amazon has already sent it to me. They are not losing my business. Cost of losing my business is much lower than the return cost that Amazon has to spend if they actually send that dishwasher. Now think about this experience, right? This as an experience to me as a user is drastically different. Now, with AI becoming so good, I think there is a near possibility of this kind of model happening, right? It may not happen at the scale of Amazon, but it can happen at a scale of maybe if I know your patterns of dishwasher, I can immediately send it to you very frequently, right? Find those kind of problems, look at those kind of things, try to kind of, this is the kind of value I'm talking about. You can reimagine the way business is done today, reimagine the way problems are solved today with the latest technology, and flip the way the business models are doing, and that will help you create amazing value for people.
Yeah, that was a great bit of information. Again, really different perspective and almost showing how it's like a, when it is a, people talk about it as a revolution and kind of flipping everything upside down. It really is that whole new business models can emerge. And uh,
Now, an question would be, Rahul, why are you not doing it? Why are you telling us to do it? And I think that is where you have that gift of youth. I have a 2-year-old daughter, a family to take care of, and if I'm going and experimenting with these kind of things right now, I'm gonna lose a lot of quality of my current life, and that was what scares me. And as uh, young kids, you have the ability to kind of take certain risks, and the risk is not no longer a monetary risk anymore, right? Earlier it used to be huge sums of investment. Now it's not about the monetary risk. People are ready to spend incredible amounts of money. Venture capitals are ready to give you money to kind of test out your theories, try out different ideas. It's only the willingness to go out and put yourself out in a risky situation or a precarious situation to kind of learn continuously, right?
yeah.
That is the only thing that is probably stopping you to be in a challenging situation. I would say like, make that leap.
Yeah. That's great to hear. All in all, I think today it was really great talking to you. Great to getting to know your first curve, your second curve, continuous pivots, what's in store. You shared some great resources like Andrew Ng's course or the book that you were mentioning. I forgot the name.
ML system design and AI engineering by Chip.
Yeah. Okay, yeah. But I think that today was really productive, and we'd love to have you on for maybe another conversation down the road as well. I mean, as things progress and as we go through this in between period. But yeah, I mean, it was really really great talking with you today. I don't know if Asha, there's any final comments.
Yeah, especially like you gave a new perspective. I learned like so much from this conversation. I think like the one thing was you compared with like the light bulb, how AI is just like, the start of the light bulb, start of electricity. I really like that part that you talked about. But, a lot of great insights, a lot of learning, and a lot of good advice. So, we appreciate it. We appreciate you coming on the podcast for our first episode.
Thank you for having me on. And yeah, feel free to connect with me on LinkedIn. I'm happy to kind of continue helping or sharing my perspective. That's the cheapest thing to do than an AI prediction right now.
All right.
Yeah,
Thank
thank you
you.
so much.
Thank you.